Myself SABYASACHI GHOSH from Department of I.T.I, Government I.T.I.
Welcome everyone. Today I will discuss on gas cutting. For cutting metallic plates, general purpose shear can be used. This process is useful for only straight line cut and up to a plate thickness of 40 mm. If we want to cut a thicker plate and also if we want to cut along a specified contour, shearing process is not effective. In such cases, oxy-fuel gas cutting can be employed effectively. With the help of oxy-fuel gas cutting, plates up to a thickness of 2 meter can also be cut. Oxy-fuel gas cutting is based on the principle of oxidizing the metal and blown the oxidized metal with the help of oxygen jet. In this method, iron or steel can rapidly oxidized or burned when it is heated to a temperature of 800 degrees Celsius to 1000 degrees Celsius, and then high pressure jet of oxygen with a pressure of 300 kilopascal is directed against a heated steel plate. Oxygen jet burns the metal and blows it away, causing the cut, which is commonly known as cuff. Oxy-fuel gas cutting was invented in 1887 by Thomas Fletcher. It is extensively used for cutting steel plates in various thickness. Oxy Acetylene gas cutting is similar to that of oxy acetylene gas welding except the torch tip. In our screen, we can here clearly see the different orifice of oxy-fuel gas cutting torch and oxy-fuel gas welding torch. Here we can see that in oxy-fuel gas welding torch there is only a hole at the center of the torch orifice, which is used to issue the flame that is used for the welding. And if we look into the orifice of oxy-fuel gas cutting, here we can see small holes around a central hole, and the central hole is used for the issue of high pressure oxygen jet, and the holes that surrounds the central hole is used for issuing the flame that is used for the oxidation of the metal. In oxyacetylene gas cutting, torch tip has a provision for preheating the plate as well as providing the oxygen jet. In oxyacetylene gas cutting, torch tip has a central hole for oxygen jet which surrounding the holes preheating flames that are shown in the figure. The size of tip is normally dependent on thickness of a plate, which determines the amount of preheating flames as well as the oxygen jet flow required for the cutting. Here we can see a table which provide us a clear reference of different plate thickness and the size of oxygen orifice diameter in accordance. If larger size of orifice is used, then larger volume of oxygen is consumed. Now we concentrate our focus on the process how a cup is generated. After the steel is heated with the kindling temperature or the temperature about 870 degrees Celsius, where the metal turns to cherry red color. At that temperature it gets readily combined with oxygen and giving the iron oxide, which follows the following reaction. The reaction may also be like that. All the reactions are exothermic in nature and provide a good amount of heat to preheat the steel, but the heat is not sufficient to bring the steel in kindling temperature, and for that reason preheating flames are combined at lower rate. The heat generated causes the metal to melt and blown away by the oxygen pressure. In fact, about 30 to 40% of metal in cup simply blown away while the rest is oxidized. Now come to the operation. To start a cutting operation, torch tip must be clean and preheating flames adjusted properly to neutral flame. After that, torch tip can be held vertically or slightly inclined in the direction of travel. Torch should be positioned above the metal at a distance at about 1.5 to 3 mm. The cutting can be started at the edge of a plate or from the middle of a plate. Cutting from the middle of a plate is known as piercing start. Piercing start may cause a ragged cut or imperfect start. Even when the cut is start from the middle of a plate, a leading cut from the edge may also be preferable to leave the imperfection away from the cut surface. After place has reached to its grinding temperature, operator should release the oxygen jet to start cutting and then moving the torch in forward direction to achieve desired cut. In oxyacetylene gas cutting, forward cutting speed is very important to maintain properly. If the torch moved very rapidly, the metal at the bottom does not get sufficient heat to get oxidized and cut, which causes very rough and irregular cut. When we move torch slowly, all preheated metal are burned by oxygen and large amount of slag is generated. Since the material is not preheated, oxygen supply has to be stopped to continue cutting. The jet can be started again only when the material reaches at grinding temperature. This started off and on of oxygen jet gives an irregular cut. Though gas cutting is more useful with thick plates, thin plates of thickness less than 3 mm can also be cut by oxyacetylene gas cutting by taking special precautions. If small tips are not available, then tips should be inclined at an angle of 15 to 20 degree. Another application of gas cutting is making bevel for edges, which can be used for welding process. To do this, torch tips should be kept at required angle of bevel and then cut is executed accordingly. Gas cutting can be done by machine or by manual method. Flame cutting machines use some type of torch tips and can control the relative motion between torch tip and the metal plate, so they can cut any type of intricate shape more accurately. It can hold more than one number of torch, so large number of identical shape can be cut at the same time. In machine cutting, the movement of cutting torch in the axis is either read optically from a master drawing or traced from a master. Alternatively, microprocessor controlled flame cutting machines are also available, in which coordinates of contour can be directly fed. Oxygen cutting is useful for those materials which are readily to be oxidized and their oxide have lower melting point than the pure metal. The oxygen cutting is mostly used for ferrous metals, but cannot be used for materials such as aluminium, bronze, stainless steel, etc., since they resist oxidation. Cutting of cast iron is more difficult since its melting point is less than iron oxide. Further, if preheating and postheating is not properly done, white cast iron can also be formed, which increase the hardness. Alloying elements such as chromium steel and nickel, when present into the ferrous alloy, interfere with oxidation that make the cutting process most difficult. Now we'll discuss about a special cutting method, that is powder cutting. This is a special cutting method created for cutting a corrosion resistant steel. In this process, iron powder injected in oxygen jet flowing through the preheating flames of the cutting torch. Instantaneously, this iron get oxidized by the oxygen jet and release enormous amount of additional heat which is required for the preheating of metal and facilitate the cutting. So this was a short discussion on oxyacetylene cutting process. Hope the total process is clear to you. Thanks for watching. Have a nice day.